The image we have of Saturn is physically incorrect. The James Webb Space Telescope has recently provided data that forces us to reclassify our long-standing understanding of this planet. In these infrared captures, Saturn no longer appears as the golden icon we recognize from textbooks. Due to methane absorption in the atmosphere, the planetary body itself looks significantly darker, in some exposures appearing nearly black, while the rings emerge as brilliant, glowing structures in stark contrast. For decades, we viewed Saturn as a monumental, static constant. Yet measurements from planetary scientists like James O'Donoghue now reveal a different reality. We are not observing a perfectly stable system. We are witnesses to a process that is measurably altering the physical composition of the planet at this very moment. The problem lies in the fact that our visual perception of Saturn suggests a permanence that is being systematically refuted by the sensors of the Cassini spacecraft and the new mirrors of Webb. The rings are losing material, and they are doing so at a rate that puts our existing models of planetary formation under immense pressure. To comprehend what is happening here, we must examine a figure clarified by James O'Donoghue's team at JAXA, based on archival Cassini data. Every single second, Saturn loses enormous quantities of ring mass. Estimates suggest that during peak phases, a total mass reaching approximately 10,000 kilograms per second plunges into the planet. That is the equivalent mass of an entire Olympic-sized swimming pool emptying completely into the atmosphere in less than half an hour. Scientists refer to this phenomenon as ring rain. It is a process where ultraviolet radiation from the sun electrically charges the tiny ice particles within the rings. Once charged, they react to Saturn's magnetic field and are pulled directly into the upper atmosphere along magnetic field lines. There, they simply vanish. What we perceive in images as a majestic, solid disk is, in truth, a system experiencing continuous material loss. This represents the first major rupture in our scientific expectations. For a long time, we assumed the rings were roughly 4.5 billion years old as the solar system itself. However, a loss rate of this magnitude is difficult to reconcile with such an advanced age. It is the observation of a system currently in a state of transition. The rings consist of over 99% pure water ice. Dr. Linda Spilker, who led the Cassini mission as a project scientist, describes the rings as a highly dynamic system, but this dynamism is synonymous with inherent instability. The ring particles exist in a state of permanent mechanical conflict. They move in an orbit between the crushing gravity of Saturn and their own centrifugal force. Yet, the electromagnetic coupling to the magnetic field disrupts this delicate balance. Imagine a factory where every component is precisely synchronized. Suddenly, the smallest parts become magnetic and begin to drift out of their orbits toward the main reactor. The structure of the factory remains for now, but the substance is being continuously eroded. This is the Saturn that our instruments are registering today. Ring rain, however, is not the only sign that the system is reacting in unforeseen ways. There is a phenomenon first documented by the Voyager probes in the 1980s that is once again raising fundamental questions: the so-called spokes. In recent images from the Hubble Space Telescope, captured under the Opal program led by Amy Simon, they are clearly visible. These are dark, wedge-shaped structures that migrate across the rings. What is unusual is not their existence, but their behavior, which cannot be explained by the laws of gravity alone. While individual ice particles strictly follow Keplerian laws, with inner particles rotating faster than outer ones, these spokes occasionally move like cohesive, rigid patterns. They appear to be coupled to the rotation of Saturn's magnetic field rather than the orbital velocity of the ring particles themselves. For scientists like Amy Simon, this indicates that we have not yet fully grasped the complex interactions between the planet's ionosphere and the dust within the rings. It is a pattern that was simply not foreseen in our basic models of planetary physics. A deep divide has emerged within the astronomical community because of this. Two explanatory models exist, both based on plausible data, yet they are mutually exclusive. The classical view assumes the rings are a primordial feature, formed from the leftover material of planetary birth billions of years ago. On the other side are the findings of researchers like Luciano Ies from Sapienza University of Rome. He utilized precise gravity measurements from the Cassini probe during its final orbits to determine the actual mass of the rings. His result was a turning point. The rings are relatively light. They do not possess the mass one would expect from a billion-year-old system that is constantly being contaminated by micrometeorites. His data suggests the rings formed only about 10 to 100 million years ago. This means that while the era of dinosaurs was already in full swing on Earth, Saturn may not have possessed any rings at all. It was a pale gas giant without its most defining characteristic. We are, therefore, observing an extremely rare moment in cosmic history. But this leads to a new question. If the rings are so young, what event created them? The destruction of an icy moon? A violent collision? We see the result, but the origin remains a scientific void, one that is being further blurred every second by the constant loss of material. Scientific caution is crucial here. It is possible that our current measurements reflect a phase of exceptionally high activity. Ring rain might be subject to seasonal fluctuations, influenced by Saturn's tilt towards the Sun, or temporary electromagnetic storms. Nevertheless, the hard data, especially the infrared analyses from Webb, shows that the discrepancy between theory and observation is real. If our models for such a prominent system as Saturn exhibit gaps, it calls into question our assumptions about the stability of exoplanets in distant systems. We are basing our search for faraway worlds on models that are currently being revised for our immediate neighbor. When we look at Saturn today, we are not seeing an eternal icon. We are seeing a system in flux. The rings are not a static monument. They are the result of a dynamic, energetic process that has a definitive end. The fact that images of Saturn look different today is due to the depth of our new instruments. They reveal a reality that is more complex and more volatile than we would like to admit. We tend to view astronomical timescales as infinite, but Saturn reminds us that even planetary structures are fleeting. If the current calculations of the erosion rate hold true, Saturn will have completely lost its ring system in an astronomically short period, within a few 100 million years. This means the Saturn we know is not a stable state. It is a temporary event. We live in an extremely narrow window of time in which this planet possesses exactly this appearance. Every look through a telescope does not show us an eternal condition, but a fleeting moment of cosmic change. Reality is not unstable. Our perception of the immutability of the heavens was. What we held as a symbol of permanence is, in truth, one of the most precise hourglasses in our solar system. And we are not watching it endure. We are watching it disappear.